Today's video is going to be about factoring a greatest common factor. To warm up, we want to first take these polynomials and simplify them. In order to do that, we are going to distribute. So a times 3a is 3a squared, and a times positive 7 is positive 7a. On the next one, if we multiply negative 2m times m squared, we get negative 2m to the third. Negative 2m times 6m is negative 12m. And negative 2m times negative 1 is plus 2m. The third one, 4x cubed y times x squared is 4x to the fifth y. 4x cubed y times negative 2y is negative 8x cubed y squared. So factoring is going to take us from here back to here. We are going to try to undo distribution in this type of factoring. So what is factoring? Factoring is separating a polynomial back into a product. So if we had a polynomial in its simplest form, that might look like this. Its factored form would be 4a times a plus 2. And we'll look into that in more detail, but if you notice, if we distributed this 4a back through, we would get this as our answer. So we're just undoing distribution. Polynomials that cannot be factored are called prime. I'm going to let you pause the video and read this really quickly. All right, so the first example that we're going to use is number 1, 3x plus 12. And we want to factor this. When we factor, we are going to check the coefficients and then look at each variable individually. So the coefficients here are 3 and 12. The greatest common factor, or the biggest number that goes into 3 and 12 evenly, is 3. Now, we have an x here, but there's no x here. That means we cannot take x out. X is not a common factor. So now we want to look at what's left. So if we distributed 3 to something, what would we have to distribute it to get 3x? Just x. And then what would we have to distribute 3 to get positive 12? It would be positive 4. And so this is our final answer. But to check that answer, we would distribute the 3 back out. So 3 times x is 3x, and 3 times 4 is positive 12. So this is correct. Let's take a look at number 6. First, we'll look at the coefficients, 4 and 24. The biggest number that goes into both of those evenly is 4. Y squared and y, you can always take out, so if there's a y in every term, if there's a variable in every term, you can take out the lowest exponent worth. So if this invisible exponent is just a 1, it's understood to be a 1. So we can take out a y because that's the smallest exponent on y in this polynomial. So we'll take out y. 4y squared divided by 4y leaves us with just y. 24y divided by 4y leaves us with 6. Now we want to check our answer. 4y times y is 4y squared, and 4y times negative 6 is negative 24y. That's the same as what we got before, as what we started with, so this is the correct answer. Now let's skip down to number 16. We've got multiple variables and lots of terms. So let's start with the coefficients, 9, 18, and 24. I would start by listing the factors of 9. So you can do 1 times 9 or 3 times 3. That's the only, those are the only factors of 9. And since 9 is the smallest number, it'll have the fewest number of factors to check. So start with the biggest one and say, does 9 go into 18? Yes, it does. But does 9 go into 24? No. So let's go then to the next largest factor, which is 3. Does 3 go into 18? Yes. Does 3 go into 24? Yes. So the greatest common factor of these three numbers is 3. So 3 is going to go on the outside. Then we look at our r's. R to the 8th, r squared, and r. There's an r in every term, so we can definitely take an r out. And the smallest exponent on r is no exponent, which is understood to be a 1. So we just leave the r with no exponent because that's the lowest one. Now for s, we have s's here, but we have no s in this term, so we cannot take out s at all. So 9r to the 8th divided by 3r gives us 3r to the 7th. When you divide with exponents, you subtract them. So this is 8 minus 1 gave us 7. Negative 18 divided by 3 is negative 6. R squared divided by r is r. And the s won't change because we did not take an s out. Negative 24 divided by 3 is negative 8. R divided by r cancels out. That just equals 1. And then the s squared stays because we didn't take out any s's. So now we want to check our answer. 3r times 3r to the 7th is 9r to the 8th. 3r times negative 6rs is negative 18r squared s. And then 3r times negative 8s squared is negative 24rs squared. This is the same as what we started with, so this is the correct answer. And the last example we're going to do today is number 24 on your paper. We're starting again with the coefficients 3, 9, and 15. 3 only has 2 factors, 1 times 3. So if 3 doesn't go into these numbers, then there is no greatest common factor for the coefficients. But 3 does go into all of these numbers. So we get to take a 3 out. Then we have a cubed, a squared, and a. A is the smallest. A to the first is the smallest, so we'll just take out an a. B squared, b cubed, and b to the fourth. B squared is the smallest exponent of our b terms, or of our variable. So we'll take out a b squared. And then we have c, c squared, and c cubed. C with no exponent, or c to the first, is our lowest exponent, so that's what we'll take out. Now, on this problem, I want to show it a slightly different way. I want to say, if we divide it, so the goal is our answer should be something that when we distribute, we get this back. So that means that this times our first term, whatever that's going to be, there will be 3 terms, should equal this term. So if we do the original term divided by this term, we should get what's here. So I am going to write this 3ab squared c, 3ab squared c, 3ab squared c. Divide every term by that and see what's left, and that's what's going to go in our parentheses. So this may make more sense to some, or it may make less sense to others, and that's okay. Just whichever way is more practical for you and makes more sense to you is fine. But when we look at the first term, 3 over 3 is just 1, so those cancel. And b squared over b squared is just 1. C over c is just 1. So the only thing we have left is a cubed over a. And we subtract these. This is a to the first, so 3 minus 1 is 2. So a squared is our first term. So I like to look if anything cancels first. So looking at the second term, none of those terms are exactly the same, so they won't cancel. So we'll actually divide. Negative 9 over 3 is negative 3. A squared over a leaves us with a. B cubed over b squared is just b. And c squared over c is just c. All right, then the last term, we have an a and an a that cancel. Nothing else is identical, so nothing else can cancel. 15 divided by 3 is 5. B to the fourth over b squared is b squared. And c to the third over c is c squared. So this should be our answer, but we're going to distribute just to be safe and make sure that we did this right. So as I check my answer, when I distribute this, the only thing in this term is an a, so the only thing that will change is the a. So the 3 stays the same. A times a squared is a cubed. And then b squared c is going to stay the same too because there were only a's in this term. All right, now for the middle term, we should look at each term or each piece of the term individually. So the coefficient times the coefficient. 3 times negative 3 is negative 9. A times A is A squared. B squared times B is B cubed. And C times C is C squared. All right, then this times the last term. 3 times 5 is positive 15. There's no A in this term, so the A will stay the same. B squared times B squared is B to the 4th, and C times C squared is C cubed. This is what we started with, so we did get the correct answer. Thank you guys for watching. Have a great day.